All right, guys. So let's discuss more about the um, next bottleneck in our approach. Until now, we have seen that uh, at some point of level, we are able to solve the database scaling problem challenge, right? Now, next bottleneck I can see now is at web server level. Till now, we have shown you that we are using only one web server, which is probably the next level bottleneck, right? So to solve that bottleneck, we have to scale our web server. And how do you scale? As I told you, scaling means from now we can only understand scaling means horizontal scaling. So we need to apply horizontal scaling at web server level. So that you need to do now onward. Okay. So let's go back to.
All right, so if you try to understand this bottleneck now, so at this place, if you look this thing, this is the bottleneck, right? Because you have only one web server, and rest all like this bottleneck is resolved now. So I can scale a database layer, this layer, for any incoming, load, right? For any incoming load from web server, I can able to handle by increasing scale factor here. But this web server is bottleneck. To resolve this bottleneck, let me go through, this approach. So just I'm making the rectification here. So what we do here is, first you introduced load balancer here. So I will introduce the load balancer, and this and this. Okay, this load balancer, this is called load balancer. Now this load balancer have, below this layer we have a multiple web server, right? We can put multiple web server below this. So say web server 1. Similarly, I can put another machine which have same configuration, and this is web server 2. Similarly, I can put another web server which is primarily web server 3, and all these are somehow balanced. Load is balanced among these web servers 1, 2, and 3 by using this load balancer. And this, this user space, client is in the intuition that he is interacting with one unit only, right? So later in I will create one diagram for it, which can explain you exactly how we are solving this problem, right? So thank you for listening me. Let's move to the now video format. All right, so let's now learn load balancing theoretically. So a load balancer evenly distributed incoming traffic among web servers that are defined in a load balance set. I will show the figure here. Look at that figure, how a load balancer works. Now, if you look there, you can see that client is now calling directly to load balancer. So client knows about load balancer only. So whenever client will try to get the IP address corresponding your website URL, they will get always the load balancer IP address, okay? And then the client will call that through load balancer IP address. Now load balancer internally transfer the load by balancing the calls as per their engagement, right? As per their engagement, they will balance the loads, transfer these API calls to different web server, and web server will finally act upon this request. And after the completion of request, they will respond with the result to load balancer via the load balancer to the client application, right? So that you can see in the picture. Now, one important point here to note that how these load balancer will not only balance the load, it also increase your server availability. So I'm giving you some theoretical understanding here. If a server 1 goes offline, all the traffic will be routed to server 2 and server 3. This prevents the website from going offline. We will also add a new healthy server. Like while going, once your system realizes that server 1 goes off, they will immediately launch new server, and that new server will add it here. So it means that now once this server is up, your system will realize that there are again 3 web server running together. Okay. So by that way, you can handle the even the web server downtime. If the website traffic grows rapidly and 2 server are not enough or 3 server are not enough for you, you will increase more web server, add more one server to handle the burst out load to your system. That is the another advantage of this scaling, right? So this seems to be more better system now, right? After adding this load balancing in front of web server, and your web server become the more scalable system, and that will eventually adding more strategically benefit to your system. So your system becomes more mature by putting this configuration, by this approach, right? Let's move to the database replication next concept. So until now, what we learned, we have assumed that how simple server client interaction is going on. Then we realize that if we put everything into one server, probably that will create more havoc problem. And then to improve that system, we extracted database part, we put it into separate web server. Then we put multiple servers, database server to horizontally scale the database requirement, and we also diverted read and write to different web server, which will actually increase the load. That will increase the overall performance of your system, and also it increase the more reliability and more addition of your user request into your database side. And after that, we realize that now next bottleneck becomes for us is the web server itself, because that is the single one right now. So to improve that bottleneck, like to remove that bottleneck, we introduced horizontal scaling in that web server. How we did? We introduced load balancer. Then we introduced multiple web server, which put in underneath the load balancer. And your client application only knows about the load balancer IP address. He is requesting whatever they want to load balancer. Load balancer internally maintain which server has how much load. Like that is definitely an algorithm. You have a smart algorithm underlying this load balancer, and they are managing that load across these web servers. And it has advantage in two major area. One major area is downtime. Another major is handling the load burst out. So these two will be handled by this approach. Thank you. Thanks for your patience. Let's move to the another key area in the next video.